My name is Piotr Kedra. I work for Juniper for almost 9 years. Now I'm responsible for channel education, channel SE. So today I want to discuss the virtualization first, and then data center architectures based on Juniper equipment. So we are living in the connected world. If I see what are you doing right now, it is a boring presentation, so let's start to play with the phone. So your phones are a few times or maybe a few hundred times faster than my first PC I had in my life. So we are well connected. So thanks to the networks, we can connect our devices to the data. The question where the data are stored. So data are stored in the data center. So this is the main topic for my presentation. So first of all, let's talk about the cloud. I think now everyone knows what is the cloud. A few years ago, we had a joke that when the cloud goes down, it changed to the fog. It was rather the fog, not the cloud. Now it's, I think, quite easy. But very important thing, if you have a look at the sky, you can see the different kind of clouds. In the IT world, it's the same. So we have a private clouds, we have the public clouds. In our region, I see it's very popular to use the governmental clouds. Maybe we can also offer, or we can use hybrid clouds, which is a combination of the private and public cloud. Whatever you want to do, it's worth to be prepared for the cloud technologies. I really like the name software-defined data center. So if you plan a new data center, if you plan some upgrades in your data center, please think about it, plan to have a software-defined data center. What is the cloud? So if we talk about cloud computing, the idea behind it is to have an open, on-demand access to a shared pool of resources. Whatever it's CPU power, memory, storage, some applications like load balancer, security, or whatever you need to realize your infrastructure. So cloud is really convenient because we can share the same resources between the many users. Some users need a lot of CPU power at the end of the month. In some data center, during the day, they are used to process data for one region of the world. During the night, they are working for a completely different region of the world. This is possible thanks to the cloud technology. I'm the big fan of the Lego bricks. People who knows me knows very well that I bought the first Lego Technic set for my son when he was 6 months old. Of course, I didn't give him to him because he could eat the blocks, but I play a lot with this. So I like the Lego, use the Lego to explain the idea of the software-defined data center. The most important bricks, it's virtual machines. As you can see on the slide, a virtual firewall, virtual load balancer, or any virtual network device, it is also a virtual machine. It's the same like the hosting web page, database, or whatever. Then we have virtual networks. You may think about virtual networks like VLANs, but it's not exactly the same. We can imagine thousands of virtual networks inside a single VLAN, thanks to the separation. And at the end, it's the gateway devices. Gateway devices are used to connect this virtual environment to the real world. Real world means campus, one network, internet, or whatever you need. If we have such blocks, you can build something like that. Have a look. It is infrastructure as a service, software as a service. It is infrastructure prepared based on some customer demand. You can see one virtual network with few virtual machines, then some virtual network appliance like virtual firewall. It might be VSRX, just presented by Carl. Then we have yet another virtual network with virtual machines. Have a look. This is BMS. BMS is bare metal server. Even in the modern data center, I see a lot of enterprises are moving to the VMware or any other hypervisor solution, but there is still a need to connect physical devices. If you need to do that, no problem at all, we can do that. And at the end, gateway device to provide the connectivity from the L3 VPN, from the IP VPN to this virtual infrastructure just created on demand. So how to do that? First, let's talk about the old school approach. So old school approach is that if we have 3 hypervisors and we want to connect the same virtual machines into the same layer 2 network, it is not easy because we have to reconfigure all the devices on the path. In the very, very old school, with the VLANs, we have to configure all the devices to pass the VLANs through the infrastructure, which is easy with the 2 servers, but it's not easy with 3, 4, 5, and more. So there was an idea that we may have a kind of controller, open flow controller, which will control all the devices on the path and dynamically reconfigure them based on our requests. It means that this switch will not switch packets based on the MAC table and forwarding table, but this switch will switch the packets based on the flow definition. Solution was nice. A lot of people really play with this, especially that the OpenFlow was it is open standard. So in theory, you can use the devices from the different vendors. The problem is that it's a death path. Even the people who created it don't believe in the success of this technology inside the data center. So what is the final solution? The final solution is an overlay network. It is completely virtual connection built, of course, on the physical infrastructure. How to do that? It's easy. You can use any tunneling protocol you know. It might be GRE. In the VMware world, it's VXLAN. In the Microsoft hypervisor, it's NVGRE. In some other open solutions, you might use MPLS over GRE, MPLS over UDP. So it's a variety of the options which allows you to transport layer 2 communication over layer 3 links. And this is the solution we have to live with. So how it works in detail. Just to help you to imagine that, I have a set of slides which shows you how it works. Just imagine a very small data center, just 8 racks. And in each rack, we have a top of the rack switch, everything connected together. I hope it is a Juniper network, so we can use virtual chassis, for example, with the router and firewall at the edge connected to the internet. So let's add computing power. So we can add a lot of servers with CPUs, with memory, with the storage. And let's install VMware on top of each physical server. Okay? So the whole idea of the SDN in those slides based on the VMware, but the story is the same for the other vendors. So the idea is we can build on top of it the network infrastructure, virtual network infrastructure, and connect virtual machines in any constellation, any combination as we want. Okay, it is easy how it works in details. So let's take the magic glass. Have a look what's going on. Just 2 hypervisors connected through the physical infrastructure. Those slides are taken from the VMware. So for VMware, network is not important. They have just 2 requirements. IP connectivity and the MTU bigger than 1600 of bytes. That's it. But as a network engineer, we know that it is not enough. So, but let's focus on this virtualization. In this box, we have networking components. We can call them SDN services. The most important SDN service is layer 2 connectivity. Layer 3 is easy. Yeah? For now, if we are connected to the public network, so we can get the connectivity over layer 3 and it's piece of cake. Layer 2, it's not that easy because we have to find a solution how to transport layer 2 through the network. I show you a few choices. Let's choose the tunneling overlay network. So the basic service, please remember it, is layer 2 connectivity. But we may also need some layer 3 devices to provide the routing between the virtual networks, or load balancers, or firewalls, or you can name it. So in such case, if we have 2 virtual machines and we want to allow them to communicate in layer 2, in SDN world, it means we enabled network component, layer 2 service, and those machines are connected to the same layer 2 component. That's it. If we want to do routing, we have to connect the routing component to both of those virtual machines. And the same for the firewall, load balancer, and anything else. The beauty of the solution is that if we have a virtual machine located on the different rack, maybe even in the different data center or completely different location, we can do the same. We can easily, from the orchestration management system, we can easily drag and drop the connection and it will automatically start to work. But automatically, we are too old to believe that it's a magic. So how it looks like. So the administrator is managing all those links through the SDN controller. In case of VMware, it's NSX controller. So the simple request, please connect those two machines together in the same layer 2 network. It is the message for vSwitches, two vSwitches. Hello guys, please create a tunnel between you, each of you. Yeah? Using, of course, for VMware World, it's VXLAN. So then we can transfer this packet through this physical infrastructure. So this is why the physical infrastructure is still extremely important. Because if you design the poor architecture for the data center without performance, with the poor latency, with poor other parameters, you will suffer. So as you can see, this real traffic is flowing through the switches. So network administrators can see a lot of traffic flowing through the infrastructure. But for those guys who are managing application, it's just a piece of cake. They can use the mouse to connect devices in the same network. So it's cool. Now you know how to communicate to virtual machines, how to place them in the same virtual network. The question is it enough? Of course, it is not enough, because it's nice if we can exchange the data between machines, but at the end we have to connect users. So for such reason, we need some networking devices which can also understand this tunneling protocol. The Lego bricks called gateway. Okay, so from the one side, this network device can terminate the same tunneling protocol. On the other side, it's normal networking device. So such devices in VMware world are called VTAPs, VXLAN Tunnel Endpoint. So might be completely automatically managed from SDN controller using multicast or OVSDB protocol. So why we need such boxes? To provide the connectivity to bare metal servers and also on the routers to provide the connectivity from the data center to internet, to campus, to WAN networks. Okay, so let's stop for a while on the slide. As I told you, this slide, the slide deck based on the VMware slides. But if you are a big fan of the Microsoft, the story is the same. Hypervisor is different, of course. Tunneling protocol is different, it's NGVRE, but the whole idea behind it is exactly the same. If you want to think about the OpenStack and KVM as a hypervisor, we can offer you our own Juniper-based SDN controller, which is called Contrail. But the story is still the same. With the Contrail, we can manage tunnels with VXLAN technology, with MPLS over GRE, over UDP, etc., etc. Okay, so this is grayed out part of the VMware slide, but for Juniper, it's a crucial part of the Juniper solution. We are networking guys, so have a look what we can offer for you. But let's start from the history. There was a man, Charles Close, who defined the base theory for the multi-stage switching network. He didn't optimize data center switches because he didn't know what is the data center and the network switch. But he optimized the PBXs, large voice switches. But we found that the same theory might be used to optimize the modern networking devices. So you may find the close topology in many, many documents in the internet as a base topology to realize modern data center, and especially the biggest ones. It is few important requirements that the switches in the core, it means the switch fabric has to be line rate, non-blocking architecture. But Based on this theory, we can offer from Juniper a few completely different architectures, different in scale. So we can start from multi-chassis LAC with some devices supporting MC-LAC and a lot of access devices connected to MC-LAC cluster. Virtual chassis fabric, I will tell you a few more words about it, which is extension to virtual chassis technology. I hope all of you knows virtual chassis. If you don't, please let us know. We can try to tell you something more about it. So it's, let's say it's stacking technology from Juniper. We can connect up to 10 switches and create a single switch from up to 10 switches. We can use the ring topology, of course, but we can also use any other topology to connect them together. So it's nice, but not good for data center, because normally in the ring topology, we have a good performance, we have a good throughput, but this throughput and performance depends on the traffic patterns. In the data center, we want to be sure that we have predictable performance. So performance and predictable performance is a completely different story. So predictability is a key. So virtual chassis fabric, it's the same story like virtual chassis, but with some architecture for the connection. So it's spine and leaf topology, or you can name it closed topology for virtual chassis. So it scales up to 32 switches connected together with 4 spines. QFabric, it's quite old technology available from Juniper, and again, it is a closed topology with 2 up to 4 devices in the middle and up to 128 switches connected to those devices in the middle. You can use it. Then the newest story from Juniper, newest architecture is Junos Fusion. I will tell you something more about it on the next few slides. But for the biggest data centers, if we think about scalability counted in thousands of racks, there is no other option. You have to use a layer 3 IP fabric. That's it. The beauty of Juniper solution is that I can offer you single QFX 5100 just for the one rack. Okay, one, it doesn't make sense. It's not redundancy. So let's use 2. We can connect 2 such switches together and create a virtual chassis. If it's, then we can grow up to 10. But before we reach the limit, I can convince you to use the spine and leaf topology with virtual chassis fabric. So we can smoothly migrate from VC to VCF. Then the limit is 32 devices. Before we reach the limit, we can start discussion about Junos Fusion. Junos Fusion can scale up to 128 devices, access devices connected to the aggregation devices. So as you can see, it's quite nice solution because we can reuse the same building blocks. It's completely opposite with our competitors. Our main competitor can also offer you a lot of architectures for data center. But if you want to move from one to the another one, you have to throw away all the equipment and buy the new one. From sales point of view, it's good, but I'm not sure if it's good for the customers. Virtual chassis fabric, it's very quick overview. I don't have too much time to present all details, but as I told you, it's a spine and leaf topology. It means closed topology based on 2 or 4 spine devices. You have to use QFXs 5100 as a spine devices, and up to, depends on the number, 30 access devices, leaves, and you can use variety of the options from the 1G switches to the 10G switches up to 40G switches in the access. So thanks to that, you can build the architecture which provides up to 32 switches, which provides connectivity from up to 32 switches, but those switches works as a single switch. There is single configuration file for everything. So what are the biggest advantages? You can see here it's a single point of management, full support for layer 2 and layer 3 on each leaf. It means we can switch locally. It's local switching with layer 2, layer 3 on each switch. It's ECMP, equal cost multipath, to spread the traffic across the uplinks from each leaf. Transit FCOE. FCOE, a lot of people asking for FCOE and no one is using it at the end. But the more important than FCOE, it's DCB, data center bridging. It's a set of the protocols required by FCOE, but now it's also required by Microsoft if you want to use something which is called SMB over RDMA. It is a new approach from Microsoft to the storages. So if you are working with Microsoft solutions, keep this in mind. Plug and play provisioning up to 32 switches, and each of those switches can be a VXLAN layer 2 gateway. So we have local switching on all ports. If you know the Junos, it's most important thing inside the Juniper, our operating system for all our equipment. So if you know the Junos, we have a separation control plane, it's a brain, and data plane, muscles. In case of switches, it is a packet forwarding engine. So the whole topology is one routing engine, backup routing engine. In Junos, we can't have more than two. So those boxes place the special law, it's a candidate routing engine. So they are not the routing engine. But in case of route master or backup routing engine failure, candidate may become the yet another routing engine. And a set of the packet forwarding engines spread across all the devices. This is how it works in detail. So we have quite nice parameters. Have a look. In the rack, we have line rate between the ports, of course, and the latency is at the level 550 nanoseconds, so it's really good number. Between any two leaves, it's 1.8 microsecond. Again, microsecond. It's really good result. So the control and data plane are really resilient because we can connect each server with the multi-home with the aggregated link to as many leaves as you want. There is a limitation with the lag, maximum 12 links, and 8 of them might be active. But besides such limits, you can connect using as many links as you want. And very important thing to my story, just to remind you, that each switch might play the role of VXLAN layer 2 gateway. So if you want to use VMware, or you are using Contrail with VXLAN as a tunneling protocol, you can terminate this VXLAN tunnel on our QFX and connect VLANs to the VXLANs. Quickly, we have to move forward to QFX 10,000. It's the latest switch dedicated, or not switch, it's a family of the switches dedicated for the data center. The difference between QFX 5100 and 10,000 is that 5100 based on the merchant silicon. It's just a Broadcom chip. Of course, there is a know-how from Juniper and our operating system, but PFE based on the Broadcom. In QFX 10,000, it is still Junos, but the chipset PFE, it's our own chip. It's the latest Q5 ASIC, so it's really fast chip. It's 2 terabit chip. It's 500 full duplex on the one side, so it's 1 terabit. And at the same time, this chip can do 500 full duplex on the other side. This chip is designed to the spine and leaf to close topology inside the line card or inside the switch to scale out, to scale to the more ports. With those switches, we can support 10G ports, 40G ports, and 100G ports as well. So it's really big box. And yet another thing, a big differentiator is that we decided to use a hybrid memory cube. So it's a special memory which is way faster than the DDR memory. If you try to compare DDR4, the latest memory for the servers, this DDR4 memory is 8.5 times slower than this one. Thanks to that, this will be the biggest differentiator between us and the merchant silicons. We can offer extremely huge buffers on each port. And this is just a few information about this chip. As you can see, it's almost everything inside. We can have a support for all the latest MPLS technologies like EVPN. I hope that was covered by my colleagues before during the data center interconnect session. We have on-chip analytics. There is a special part of the code inside the chip, and this special part of the chip can monitor all the counters on the links, and we can detect situation like microbursts, some issues with the buffers, and we can report it proactively to the management team. Of course, support for layer 2, layer 3. In Juniper, we don't have layer 2 devices at all. High frequency monitoring and PTP, so it means we can precision time protocol. We can support precision time protocol to distribute the time information. It's ready for 400G links. It is not a joke. We did test 400G links just a few months ago. In Poland, there was a connection between Poznań and Warsaw. It shows me that people want to have a faster and faster links. So I don't want to just read the slide, but it's a lot of nice features. So I promise you to present the data center architecture. So the latest architecture for data center is Junos Fusion, but Junos Fusion, it is one technology for 3 use cases. So how to differentiate case A, B, and C. Case A is for provider edge. Junos Fusion for data center is something which interests us a lot, and Junos Fusion for the campus. This is how Junos Fusion looks like. It is 2 aggregation devices connected together. It is like a multi-chassis lag, and a lot of satellite devices connected to those 2 boxes. So how to differentiate all those 3 use cases? It's very easy, by aggregation device. So if the aggregation device is MX, it's Junos Fusion for service providers, for provider edge. If the aggregation devices are QFXS 10,000, it is Junos Fusion for data center. If aggregation devices are EX 9200, it is the Junos Fusion for campus. So you have to be careful, because this is the same technology, but you may notice some difference between each of those 3 use cases. But for going back to the data center, we can scale with this really easy way up to, in the first list, it will be 64 devices, satellite devices, but at the end, we want to scale up to 128 satellite devices. So just to present you, I have to show some terminology. Aggregation device, you know what's that. Satellite device, you know as well. So aggregation satellite extended ports are the access ports. Upstream ports are the upstream ports from satellite devices, and cascade ports is downstream ports on the aggregation devices. That's all names you need to understand how it works. And inside the data center, you can use QFX 10,000 as an aggregation device, and all QFXs 5100 and EX 4300 as the satellite box. How it works? So QFXs 5100 are still using Junos, but those aggregation devices. Satellite devices will use some special software, Satellite Network OS, which is based on Wind River Yocto Linux. And we are using some protocols to communicate between the aggregation and satellite devices. Those protocols are LLDP, AO2.1 BR, and JSON RPC. I think you can see more details on this slide. LLDP is used for automatic detection of the satellites and automatic provisioning of the satellite devices. AO2.1 BR, it is a protocol, open standard, which describes the fabric extenders. We found that it's nice as a base protocol, but it's not good enough for our needs. So we decided to extend it a little bit. This is why you see a plus at the end. So this protocol is used only for fabric extenders, means each packet from those switches are going up from a satellite to aggregation device, and then is going down to the other port. In the data center, it is not the best solution. In the data center, we also want to support local switching. So no way to support local switching with BR only. So we decided to extend this with JSON RPC, and then thanks to that extension, we can also support local switching. Plus 2 other standards, netcon for configuration synchronization between devices, and ICCP, it is a protocol to synchronize multi-chassis link aggregation. So it's used only between the aggregation devices. So it's really simple to operate it, because wherever you connect, this is a management point. Those two boxes will handle the whole configuration. All the changes are made on those two boxes. We have a flexible deployment models. So you can imagine that in the single data center, you will have the whole Junos Fusion, means two aggregation devices and a lot of satellite devices, or you can split aggregation devices between the sites, but it's still possible to create aggregation link to any of two satellites. That's also explanation how the modes of operation works. This is the extender mode. Each packet from the satellite devices is sent to the aggregation device. It looks like it's not optimal, but thanks to that, you have full aggregation devices capabilities available at each port of the satellite switches. That's the whole magic. But as I said, inside the data center, local switching is very important, because thanks to the local switching, we can speed up the operations. So thanks to the JSON RPC, we can program the local switches, satellite switches, and those switches will be able to switch traffic locally. And of course, for the bigger data center, and also my standard joke is, what is better than data center? Who knows? Two data centers, thank you, exactly. So with the two data centers, we have to connect them somehow, and my colleagues show you how to do that. But thanks to the QFXs 10,000, which have full support for MPLS and EVPN as well, we can create connect the two data center at the aggregation devices level. So we'll still need some routers to connect to the ISPs, campus, whatever, but you can save one hop hint to your infrastructure for the data center interconnect. So I think it's time for some summarization. In the Juniper, we have a variety of the options available for the data center. For us, we have a full respect to your data center, no matter if it's 2 racks or 2,000 racks. And the good news is that if you have 2 racks, you can start with QFXs 5100. And if you expect from us design for 2,000 racks, we will also base on the same boxes. So whatever you want to use today, we can reuse the same devices in the bigger scale. My favorite choice for current data center is, of course, virtual chassis fabric, because it's really easy to manage. There's a lot of advantages. And if the limit 32 devices is too low, too small, it's too small size for you, keep in mind you can easily switch to Junos Fusion, which allows you to scale up to 128 devices with the 40G links between the aggregation devices and satellite devices. But stay tuned. In the nearest future, we can expect some satellite devices with 100G links. So it's really future-proof technology. And if it's not enough, if you want to build a huge data center with thousands of racks, please give us a chance to make an offer for you. But for this size, open, close architecture based on layer 3 fabric is the only choice we can offer. If you want to read something more about it, please don't forget about the MetaFabric. MetaFabric, it's not technology, it's not a single product, physical device. It is a combination of the devices, APIs, technologies inside, and very good design guides how to properly design a data center. So please search for MetaFabric on our web pages, and you can find how the different architectures with the different models can cooperate with the VMware environment or Contour, depends on your choice, depends on your site, and how we can support multiple automation orchestration systems, virtualization systems, and also IT system management and other applications. So the questions, do you have any questions?